In this video, we're talking about some properties of rational functions. And for example, here's a graph of a rational function, and also called the reciprocal function. So this first one is f of x equals 1 over x. So as x gets big, the curve approaches the x-axis. As x gets near 0, it goes up towards infinity. That's as it gets towards 0, as you're coming from the positive or the right side. As it gets towards 0, coming to it from the left side, it's going towards negative infinity. And as x gets really, really small, like to negative 10, negative 20, negative 100, it's getting close to 0. And then for 1 over x squared, because it's squared, that negative goes away. And so in both cases, it'll be approaching the x-axis, going up as x approaches 0 from either side. And as x gets really small or gets really large, it's going to be going towards infinity. Sorry, it's going to be going towards the x-axis as x goes towards infinity. A couple of notations here. X goes to a with a little minus sign. That means that x approaches a from the left side. X goes to a with a little plus, means x approaches a from the right side. So back up here, this is approaching 0 from the left. The right side would be the x approaching 0 with a plus sign would be here. X approaching 0 from with the little minus sign, it would be this side over here. And then x goes to infinity, x approaches infinity, increases without bound, x approaches negative infinity, decreases without bound. F of x goes to infinity, that means the output values are going to be going up without any bound. And f of x approaches negative infinity, means it's going to be going to negative infinity without any bound. And if f of x approaches a number, a, the output approaches that number. So our local behavior, I want to share this with you with an accompanying graph just to see what's happening. So see, here we have x is really small, or it's near 0, negative 0.1, negative 0.01, negative 0.001, negative 0.001. And we look at this in the context of 1 over x. So 1 over negative 0.01 is negative 10. 1 over negative 0.01, sorry, that was 0.01. Negative 0.01 is if you put that under x or under 1, you get a negative 100. And so on, you get negative 1,000 and negative 10,000. Likewise, as x becomes 0.1, 1 over 0.1 is 10, 1 over 0.01 is 100, 1 over 0.001 is 1,000, and 1 over 0.0001 is 10,000. And that's why as x gets really close to 0 here, it's going up to infinity. As x gets really close to 0 from this side, it's going to go down to negative infinity. So as x approaches 0 from the right side, it's going towards infinity. As x approaches 0 from the left side, it's going to negative infinity. And as x gets really big, like it's here, if it's 4, then 1 over 4 is 0.25. If it's 1 over 10, it's 0.1. If it's 1 over 100, it's going to be 0.01. So this is getting closer and closer to 0, just like this is getting closer and closer to 0 as x gets really big. So looking at this graph, this orange line is called an asymptote. It's a line that the graph approaches but does not cross. So this is a vertical asymptote. Vertical asymptote of a graph is like a vertical line x equals a, where the graph tends towards the positive or negative infinity as the inputs approach a. We write, as x approaches a, f of x goes to infinity, or as x approaches a, f of x approaches negative infinity. In fact, in this one, we'd say, as x approaches 0 from the right side, f of x approaches infinity. As x approaches 0 from the left side, f of x approaches negative infinity. In behavior of f of x equals 1 over x, so as x goes to infinity, f of x goes to 0. So as x gets really big, it's 1 over x, so it's getting closer and closer to 0. And as x goes to negative infinity, it's still approaching 0. but from underneath, but it's still going towards that 0. And so we have the vertical asymptote at x equals 0. We also have a horizontal asymptote because both of these lines are approaching this horizontal line, y equals 0. So that's a horizontal asymptote. And a horizontal asymptote of the graph is a horizontal line, y equals b, where the graph approaches the line as the inputs increase or decrease without bound. We write as x goes to infinity, or x goes negative infinity, f of x approaches that value b. So use arrow notation to describe the end behavior and local behavior of the function. So end behavior means as it gets big. So as x goes to infinity, I guess we're calling this f of x, goes to, well, it looks like it's approaching 4. As x goes to negative infinity, f of x also approaches 4. So both, that's going towards 4, this is going towards 4. But as x gets close to 2, it's approaching infinity. As x goes to 2 from this side, negative infinity. So as x approaches 2 from the right side, a little plus there, f of x is going towards infinity. But as x approaches 2 from the left side, f of x goes to negative infinity. Okay, next one, sketch the graph of the reciprocal function shifted. I think it's shifted. That's got to be a D. Shifted 2 units. Wow, typos. To the left and up 3 units. So identify the horizontal and vertical asymptotes. So normally it would have been like here and here. But now it's going 2 units to the left. Let me change colors here. So 2 units to the left. And so that means that this vertical asymptote is going to be here instead. And then it's going 3 units up. So the horizontal asymptote is going to be up here. So this must be looking something like this. So as x approaches negative 2 from the right side, f of x goes to infinity. As x approaches negative 2 from the left side, f of x goes to negative infinity. I kind of did these in a different order than the other ones. As x goes to infinity, f of x is approaching, looks like 3. And as x goes to negative infinity, f of x also approaches 3. Let me clean this up because it's going to cause some confusion, I fear. Okay.